Okay, let's continue our discussion. So, in the previous video, we have discussed these two questions from your NEET 2024 paper. Now, we are going to discuss the questions from your NEET 2023 paper. And here we have the question: the angular acceleration of a body moving along the circumference of a circle is. Now, we have to obtain this thing, the direction of the angular acceleration actually. So, let's say this is body moving on a circular path, and this is center, and let's say this is z axis about which this body is moving. So the movement, let's say, is this way. We can say angular velocity is along this z axis. Now the angular acceleration depends on torque this way. So if we want to know what is the direction of torque first, then we can consider the same direction for angular acceleration. So let's say this body has velocity along negative x direction. So this is x direction, x axis actually, this is positive x direction. So this is y axis. So let's say it has velocity along negative x direction this way. So velocity equals to velocity, magnitude of the velocity times unit vector along negative x axis. Okay. If there is a force acting along the velocity, which will be tangential to the position vector here perpendicular actually means tangential to the circumference. So in this case, the force is along, let's say this is force is along negative I cap. So this is position vector, let's say r, and this will be r j cap based on the standard notations for unit vectors along different axes. So we can say r cross f, which is torque. This will be rf, and this angle is 90 degree. So we need not to write sin 90 degree as it will be 1 only. So further we have j cross minus I cap here. J cross minus I cap. It will give us RF K cap. So we can say that torque in this case, when force is acting along the velocity, so at the end it is going to increase its linear velocity, which will result in increasing angular velocity. That is, there is an angular acceleration along the angular velocity. So in this case, the angular velocity as direction along this positive k cap or along the positive z direction. Okay. Now, what if this force is acting along I cap? Look, this is tangential, but just opposite to the direction of this velocity. In that case, r cross f will give us j cross I, which will be minus k cap. And in that case, the torque is acting along the negative z direction for this force here. So angular acceleration is acting along the negative z direction in this case. At the end, the angular acceleration is acting along this z axis. This is what the axis of rotation. Okay. Now moving to the next question. The radius of gyration, ratio of radius of gyration of solid sphere of mass m, radius r. Let's say here we have solid sphere and mass is m and radius is r. About on axis means the axis which is passing through the center of this sphere. So let's say this is axis of rotation. So this will be 2 by 5 m r square, moment of inertia about this axis, m r square. And we know in terms of radius of gyration and total mass, we can write moment of inertia as m k square. So equating these two things, you will get k square equals to 2 by 5 r square. In case of hollow sphere, we will have I equals to, in the same way, we will have I equals to 2 by 3 m r square, and this thing we can equate m k square as we have done here already. So this will be k square equals to 2 by 3 r square. Now we have to take the ratio of these two things. Let's say here 0.1 and here 0.2 actually. Means in case first case, in the second case. So k1 square by k2 square we have 2 by 5 r square divided by 2 by 3 r square, which will be 3 by 5. But mind it, here we have to find out the ratio of radius of gyration, not the square of that thing. So this k1 by k2 will be under root 3 by under root 5, which is not matching here. So there is no option provided here for this question. Okay, now moving to the next one. The angular speed of a flywheel moving with uniform angular acceleration changes from 1200 revolution per minute to 3120 revolution per minute. So let's say this is initial angular velocity or angular speed if we are ignoring direction for time being. So 1200 revolution per minute. And we know in one revolution, it will cover an angular distance of 2 pi radian. So in 1200, it will cover this much radian of angular distance. So this much angular distance covering in 1 minute. So to get in 1 second, we have to divide this thing by 60. So here we will have initial angular speed in radian per second, and this will be, I guess, 40 pi radian per second. Now, final angular speed will be in the same way 23120 into 2 pi by 60 radian per second, and this we can find out 005 and 2, and then it will be 104 pi radian per second. Now we can obtain what is the angular acceleration. This will be 104 pi minus 40 pi, means final angular speed minus initial angular speed divided by time, which is 16 second. And this will be radian per squared second. And you can solve it. It will come 4 pi radian per squared second. So we can write that answer is here. Okay, this is pi, pi. Okay, 4 pi. Now moving to the next question. The ratio of radius of gyration of a thin uniform disk about an axis passing through its center and normal to its plane, okay, to the radius of gyration of the disk about its diameter. These two ratio we have to uh, find out here for these two things. So the ratio we have to find out, like we have a disk here and there is an axis of rotation which is passing through its center and perpendicular to its plane. So let's say this is z axis. So IZ will be m r square by 2. We have already seen these things. Now, what about the axis which is along its diameter and in its plane? Let's say this is y axis. So we can apply the perpendicular axis theorem. So perpendicular axis theorem, what we can write if we want to know what is Iz. So Iz will be Ix plus Iy, means the moment of inertia about this axis, which is perpendicular to the plane of this disk, will be the sum of these two moments of inertia which are along the axis in the plane of disk, and these two are perpendicular to each other. So this is what perpendicular axis theorem tells us. Now we can write Iz is m r square by 2, and look, about x or about y, moment of inertia will be same because this is a symmetric body. So no matter you are choosing this one or this one. So let's say this is equal to 2ix. So ix equals to m r square by 4. Now, we know we can express this thing in terms of total mass and radius of gyration. So, about z-axis, let's say we can write m k. Let's say this is radius of gyration about z-axis, m k square. So, from here, we will have k z square equals to r square by 2. Now, what about this case? So, m kx square will be m r square by 4. So kx square will be radius of gyration about this axis, both are same actually. So this will be r square by 4. Now we can find out the ratio. This implies k2 square, sorry, kz square by kx square will be r square by 2 divided by r square by 4. This will be 4 by 2 ultimately. You try it by yourself, and then we will get kz is to kx. This will be under root 2 is to 1, because look, this is going to be 2 by 1. So here we have the answer. Now moving to the third one. So what is it saying? Two objects of mass 10 kg and 20 kg respectively. So let's say we have a body here of 10 kg and another body here 20 kg, and they are at the end of at the two ends of a rigid rod of length 10 meter. So let's say this distance is 10 meter. Now we have to find out the distance of center of mass from the 10 kg. Yes, 10 kg object here. So what we can do, we can take a reference point here. Let's say this is z axis we used to choose, and let's say this is y axis. So let's say there is center of mass at this point, which is at y, means this length is, let's say, y. So this y can be given as y equals to m1. Let's say this is m1 and this is m2. So this will be m1 into r1, and this body is lying on the origin or reference point, so r will be 0. So this thing is 0, m1 into r1 plus m2 into r2. m2 is 20 kg into r2. r2 is, look, r2 is this length actually from here to here, which is 10 meter. So r2 we can write uh, 10 meter, and then divided by m1 plus m2, which will be 30 kg. So we can write it 200 by 30 meter, or we can write it how much, 6, and then point, I guess it should be 6 7. So or we can write it 20 by 3 as it is here. So this is all. Okay, this is all for this video. In the next video we will continue our discussion and we will solve these questions.